Happy Friday, everybody. We're going to do a quick little video on completing the square day 3 notes. Now we're going to try to bring everything together, and next week we'll kind of be wrapping up this equation of a circle section. We're going to bring it all together and show how completing the square can lead us to graphing those circles and to the equation of a circle. So let's get right into it. The steps for completing the square are listed right at the top of the notes, so you should review those. These are things that we should be committing to memory, but it might be helpful. You might even want to, I hope you're printing these, but if you don't have the ability to print, you can almost copy these notes down on an index card and keep that handy. You could title it, How to Complete the Square, and that's a good point of reference that you could go back to. So, to complete this square, we're going to complete the square on these bottom examples, and from completing the square, we're going to be able to see the equation of a circle to determine the center and the radius of that circle. So let's complete the square. In order to complete the square, we're going to move this constant to the other side of the equation. So check out how I start off by writing this. I like to leave a blank that indicates that I'm going to be including something in that spot. Now, I move the 8 to the other side. I put those two blanks there just to show, hey, I'm going to add something in there. That's going to be by completing the square. I need a new term to complete the square. The way to complete the square is we're going to take half of that linear coefficient, or half of the middle term, the b term, and square it, and that's what we're going to add in. Make sure we add it to both sides of the equation. So we take half of 4, that's 2. 2 squared is 4. We take half of -2, that's -1. -1 squared is 1. So this is what it's going to look like. Plus 4 plus y squared minus 2y plus 1 equals 8. Now watch what happens. These are the terms I added in. So I also need to add in a 1 and a 4 on the other side as well. Now we can factor this. This is x plus 2 squared plus y minus 1 squared, and combining our like terms on the other side, we have 13. This is the equation of a circle. From here, we should be able to recognize the center and the radius. The center is right here and here. My center is -2, +1. My radius is radical 13. Remember, this is the radius squared in the equation of a circle form. So to find the radius, we would take the square root of the other side. Also, thing to note in this first problem, that center, because of the equation of a circle, we really see, I don't like to just say, hey, it's the opposite, but you can almost picture it like that. It's really the opposite of what we're seeing here, because the original equation does have a subtraction sign as part of it. So this is really like saying x minus -2, or double negative makes a plus. That's why we see a +2 there. So my center is -2, 1, and my radius is radical 13. Likewise, we can do that same example on part B, or similar style of example. Notice my constant's already on the other side, so I don't need to do that. To complete the square, remember, adding in something here. So this is just my setup. I like to set up this way, again, just to kind of represent that, hey, I need to add in a new term here to make this a perfect square trinomial. Half of my linear terms squared is what we're going to fill in. Take half of -8 and square it. Take half of 10 and square it. Now I'm just copying this line down below. Also, to include that, I'm going to add in 16 and 25 to the other side of the equation. Once we have that all written out, now I'm going to factor it. These are perfect square trinomials. This is why we do completing the square, because I want to be able to factor this like such. I want to be able to write it as a perfect square trinomial, a perfect square trinomial into a binomial. A single binomial squared. And on my right hand side, we get 31. Center and the radius is now very evident from that equation. We can see the center. This is the x coordinate of the center, the y coordinate of the center. The radius is again the square root of this term, because that term represents radius squared in the equation of a circle. Now, let's check out some examples. We're actually going to be able to graph some of these perfect or completing the square and equation of a circle. We're going to be able to graph them after we're done. So we're going to do the completing the square example on part A. It's very similar to how we would do our first two as well. We're going to move the constant to the other side and then do those 4 steps that's listed right under as the do now to complete the square. Just like I told you guys earlier, I like to leave that little blank there, just kind of as a setup. I think it provides a nice visual of, hey, I'm adding in something into that spot. Notice we move that 3 to the other side of the equation by adding 3 to both sides. Now to complete the square, we gotta ask ourselves, well, what do I need to put in here? Well, I need to take half of my linear term, square it. Half of 6 is 3, or negative 3, and negative 3 squared is 9. Half of 4 is 2, and 2 squared is 4. I'm also adding in that 9 and that 4 to the other side. Now I can rewrite my left-hand side in factored form. And my right-hand side we just simplify by adding 3 plus 9 plus 4. Well, look at my center now. My center is given by these 2 coordinates. My center of the circle is 3, negative 2. My radius is the square root of this term. My radius is 4. Well, a circle with a center of 3, negative 2 and a radius of 4 is something that we can graph. So I identify my center, 3, negative 2. There's our center. And I can use my radius now to plot 4 other points. I'm just going to count 4 up, 1, 2, 3, 4. 4 to the right, 1, 2, 3, 4. 4 down. And 4 left. These are the points that I can use to construct a circle. And now we'll simply construct a circle. Now, if you have a compass available to you, you can use a compass still and mark your center with your metal, with the metal part, the metal pointer. Or you can just freehand it and you get kind of an ugly looking circle, but we get the main idea. Going back up here, I'm going to leave part B as an exercise or an optional exercise for you guys to complete. But I just want to review real quick the process of this. We're trying to get from this equation into the equation of a circle that we're used to seeing. So in order to do so, we use the completing the square process to create these perfect square trinomials that then we can factor. Once we have those factored forms, now we can clearly identify the center and the radius. Once we know the center and the radius, then we can graph on our graph paper. If you do not have graph paper or a printer, that's fine. You can make a rough sketch of a graph, simply, rough sketch of a graph, and just kind of plot some points, etc. Okay? The homework is also attached to this assignment. Good luck. Email me, comment on Google Classroom, and reach out to me if you guys need any help or have any questions. And the last assignment that I didn't quite list is have an excellent weekend. Stay safe, stay healthy.